Before we can jump into sedimentary rocks, we have to talk about sediments and how they form through a process called weathering. So weathering is just a way to transform a rock. And there are two basic ways that this can happen. It can happen physically or chemically. So the way that happens physically is called mechanical weathering. Here we're just breaking the rocks down into smaller pieces. On the other hand, we can also see chemical weathering, and this is where we're going to chemically transform a rock. And we see that mechanical and chemical weathering generally happen hand in hand and occur simultaneously. And we will see that once that rock has been weathered down, it's been broken down in some way, erosion is going to transport, it's going to move that weathered and broken down rock somewhere else. So we're going to start talking about mechanical weathering, and then we'll switch into chemical weathering at the end of this video. But mechanical weathering is just breaking down rocks into smaller and smaller pieces. So think about if I have a small boulder of a rock, and I have a hammer and I just break it into, let's say, 5,000 smaller pieces. That's mechanical weathering. Each time I break that rock into a smaller and smaller piece, each piece keeps the same physical properties that it had as when it was a larger rock. But what I'm doing by breaking it down into smaller pieces is I'm actually increasing the surface area on each individual piece, which will allow chemical weathering to occur, which in case will cause the rocks to break down even faster. But another type of mechanical weathering that we commonly see is something called frost wedging. And this is something that happens when liquid water gets inside of a crack or some kind of hole and then freezes into solid ice. Water is kind of weird. It's one of the few fluids on our planet that actually expands when it freezes. Most other fluids actually condense when they freeze, but water expands by about 9%. So if water can get into the cracks when it's a liquid, when it freezes, it's going to expand those cracks by about 9% every time it freezes. So if we have periods where lots of freeze-thaw cycles are happening, where we have several days where that liquid water is freezing into ice, that crack is just going to keep growing in size until eventually an entire piece of rock can break off. Another type of mechanical weathering is called sheeting. And this happens when we have those intrusive igneous rocks, the ones that are forming from magma deep inside of the earth. When they form, they have lots, maybe even miles thick of rock and sediment on top of them. But over millions of years, all of that rock and sediment is going to be moved somewhere else, exposing this igneous rock that was used to be deep underneath the ground. When this happens, all of the pressure that igneous rock had been under for millions of years is being released over time. So the rock is going to want to expand as all of that weight and pressure is being removed from it. But as the rock expands, it's going to sheet. We're going to see that thin sheets of rock are simply going to slide off the sides of these rocks, which you can see in the right-hand side of this image. And our final type of mechanical weathering is weathering that happens from plants and animals, or what we call biologic activity. And this can be something like a plant or a tree root digging down inside of the sediment, including burrowing animals digging holes and dens, as well as decaying organisms. Once they die, they'll decay and start producing acids, which will further break down the rocks chemically. And there are several different types of chemical weathering, but the main things that we're going to be concerned about is how chemical weathering works. And this is the type of weathering where it's actually going to alter the internal structure of the minerals. So with mechanical weathering, we were just breaking it down into smaller pieces. But with chemical weathering, we're actually going to alter the inside of these minerals by either adding something or removing something from that crystalline lattice. So we're going to see that our original substance is going to change into a new material. But through this change, it's actually decomposing. It's getting lesser in quality. But by decomposing like this, it's going to make the outer layers of that rock more susceptible to further weathering. And a really good example of this is a rusty car. In this image, we can see this old car that has a really thick layer of rust. When this car was first produced, I bet it looked fantastic. But over time, chemical weathering happened. Water was able to get into that metal, and it was able to chemically alter the inside of that metal, leading to a layer of rust, which decomposed that metal into a new stable material. The exact same thing happens with chemical weathering of a mineral. And just like in the car, we see that the most common agent of chemical weathering is water. And that's because water has lots of oxygen dissolved inside of it. And when water gets in contact with metals, it can cause something called oxidation to happen. And oxidation is exactly what we see when we're looking at rust.